And now we will continue our discussion of parametric equations and curves, and we're going to talk about arc length. And I want you to remember previously in this semester, earlier in Calculus 2, we had an arc length formula. And this is the same formula written two ways, but the one I believe I mostly used in class was this one. And so what we're looking at here is going to be the integral when x is going from a to b of the square root of 1 plus that derivative dy dx quantity squared. And because we're integrating with respect to x, we know our bounds are in terms of x. So the only thing that changes here for arc length with parametric equations is that differential. And so we have the integral from t equals a to t equals b, dx dt quantity squared plus dy dt quantity squared with respect to t. Okay, so again, because this is t, I know that my limits of integration are my t interval. So let's do an example where we find the length of a curve. So here we are going to find the length of a curve, which is defined parametrically. And according to our formula, we need the derivative of x with respect to t as well as the derivative of y with respect to t. So we'll start by doing that first. Dx dt is just t. And dy dt, the derivative of y with respect to t, we have to use our chain rule to find the derivative. So actually, before I do this, I will rewrite that just a little bit and say, well, we've got y equals 1/3 2t plus 1 to the 3/2. So dy dt equals the 1/3 stays. We're going to multiply. We've got 3/2 2t plus 1. Subtract 1 from that power gives us 1/2. But remember, chain rule with the derivatives, we need to multiply by the derivative of the inside, which would be times 2. So this simplifies, and dy dt, the 3's cancel, the 2's cancel, and I end up with just 2t plus 1 to that 1/2. So now that I know both of my derivatives, we know that arc length is the integral from a to b, and that would be 0 to 4 of, my integrand is the square root of dx dt, quantity squared, plus dy dt, which is 2t plus 1 to the 1/2, and that is squared. So differentiating with respect to t. And of course that 2 and the 1/2, that's nicely cancels there. So I've got the integral from 0 to 4 of the square root t squared plus 2t plus 1, integrating with respect to t. Now, what we have under our radical here is a perfect square trinomial and could be re-represented as t plus 1 quantity squared. So we see that the square cancels the square root or vice versa. This is the integral from 0 to 4 of t plus 1 integrated with respect to t. The integral of t is t squared over 2, and the integral of 1 is just t. So we need to evaluate this from 4 to 0. And I get 4 squared over 2 plus 4 minus 0 squared over 2 plus 0. And that is all 0, so I have 16 divided by 2, 8 plus 4. My arc length is 12.